Hi and welcome to this A-level physics session where we are going to look at Newton's 3 laws of motion. So not only do we need to be able to quote Newton's 3 laws of motion, we also need to be able to apply them to certain situations. And there's an accompanying worksheet that comes with this video that gives you some past exam questions around Newton's laws of motion. Now, these can be quite big mark questions. They tend to be slightly lengthier, perhaps with a written component, where you are asked to use Newton's laws of motion to explain what's happening in a certain situation. So before we dive into looking at how we might answer a question like that, let's understand Newton's 3 laws of motion. So you'll hopefully be nice and familiar with these. If you're not, then here is a good introduction / recap. So Newton's first law is that an object remains stationary or moves at a constant velocity unless acted upon by a resultant external force. And we should hopefully all be really familiar with this. We're surrounded by objects all the time that are just as they are. They're not moving, they're not randomly leaping off the table. And that's because there is no resultant external force acting on them. Things accelerate, i.e. they change velocity when we have a resultant force acting on them. Hopefully that's nice and straightforward. If you haven't got this written down as a definition card to remember, then I thoroughly encourage you to do so because it would be such a shame to lose marks in an exam being able to quote these 3 laws. Newton's second law. Now, Newton's second law, when you were at GCSE, you would have learnt Newton's second law as F equals ma, force is mass times acceleration. However, there is a more formal definition of Newton's second law that we need to be familiar with, which says that force is equal to the change in momentum over time. Now, we're going to have a look at what exactly this means and how we can turn this into force equals mass times acceleration. And you probably don't need to know totally how this works, but it's always good to understand how to connect one to the other. So I can write that my force is equal to my change in momentum, and momentum is mass times velocity, over the change in time. Now, if my mass is constant, then my mass can't change. So I could rewrite this as mass times change in velocity over change in time. And change in velocity over change in time is acceleration. So that's how I get F equals ma. But strictly speaking, we should write it as change in momentum over time because we cannot guarantee that the mass of our objects is constant. An example of this might be something that's shedding mass as part of a collision or a rocket that's getting rid of fuel. So our Newton's second law, if we're asked to quote it, is force is change in momentum over time. Okay, awesome stuff. And finally, our third law is that for every action, there is an equal but opposite reaction. Now, this is the easiest one to state, it's the easiest one to remember, but it's also the one that everyone seems to get confused by. And the reason for this is we understand that forces come in pairs, and they're called Newton's third law pairs. So as I exert a force on something, that object is also going to exert a force back on me. A classic example of this is if I'm standing on the ground, I am pushing down on the ground and the ground is pushing back up on me. And so we would call those a Newton's third law pair. I'm pushing down and the ground is pushing up on me. Newton's third law pairs act on 2 objects. So 2 objects into contact exerting a force on one another. And the forces are equal in magnitude but opposite in direction. Okay, they're always the same type of force, so they're equal but opposite in direction. And that is a Newton's third law. That's Newton's third law, and that's how we understand a Newton's third law pair. So We're now going to have a look at an exam style question where we would need to use Newton's laws to answer the question. So this is a genuine past exam question. It's quite an old one now, but there are some more recent ones on the worksheet that goes with this video. So the photograph shows a toy car driven by air from a deflating balloon. So air is escaping from the balloon, causing the car to move forwards. Use Newton's first and third laws of motion to explain why the air coming out of the balloon causes this. Have a think, have a go at jotting down your answer. This is a 3-mark question, so we're going to need a little bit of detail. So have a think, and I will pause the video if you're still pause the video if you want some time to work it out, but otherwise here's what we would need to write. So we would need to say that Newton's first law, Newton's third law. We've got a Newton's third law pair, where we've got the force of the air coming out of the balloon causes an equal but opposite force pushing the car back. So as the air is released from the balloon, that causes an equal but opposite reaction force, causing the car to move forward. So we have a Newton's third law pair. If we then have a force acting on the car that pushes it forward, that, according to Newton's first law, will cause it to move because it now has a resultant external force pushing it forward. And by stating, so our Newton's first law, so if we stated Newton's third law and that we have a Newton's third law pair from the air escaping from the balloon would cause an equal but opposite reaction force on the car, that would have gained us 2 of the marks, and the 3rd mark would have come from stating that Newton's first law means if there is now a resultant force on the car, it is going to move forwards. It's going to accelerate. And that's it. For 3 marks, that's all we needed to state. So just having a really clear understanding of those 3 laws of motion and being able to apply them to a situation, and if in doubt, quote the law. If in doubt, start by quoting the law and then work out how it applies to the situation. Now, there's a total mix of exam questions in the worksheet. I thoroughly encourage you to go off and have a go at those. There are worked solutions as well. If you have any questions or comments, then pop them in the box below. But otherwise, thank you for watching, and I will see you next time.